Till now, we have discussed what is differentiability, how do we differentiate, correct? Differentiation part is done. Now, in differentiation itself, there are multiple types of differentiation. Like we have different types of functions, isn't it? Like we have inverse trigonometric function, we have logarithmic function, exponential function. Likewise, there are different types of functions. Now, every time we have a different type of function, we do the derivative in a little bit different way. Understood? Now, in this particular video, we are going to see one particular type of function and how do we differentiate that particular type of function. All right, let's see what it is. Now, the type of function what we are doing now, they are called as implicit function. So, implicit functions. Now, what is the meaning of this word implicit? Guys, this is a very, very important word. Okay, the reason what we mean by implicit. Now, there are two types of functions. All right, so in functions itself, there are two types. The first one being an explicit function, second one being an implicit function. Now, till now, the examples what you have seen and the problems what you have solved, they're all explicit functions. All right, the meaning of explicit in the sense y and x are two separate entities and you have a relation between x and y. All right, in the sense x and y are separated by a particular mathematical symbol. Generally, it is equal to, but not necessarily always. Okay, but generally, most of the times. So you have two variables, x and y. Both are related to one another, but both of them are separate. Like you can write it like this. You can have 2y is equal to x square plus x minus 1. Here, x and y are related to one another, but they are not together. That means x and y are not part of the same function. Correct? These are what we call as explicit functions. They are related, but they are not part of the same function. Whereas when we talk about implicit functions, all right, so implicit meaning both x and y will be a part of the same function. Okay, now you can write it an implicit function something like this: sine of xy is equal to y plus x. See that sine of xy. Now both x and y, both of them, they are part of the same function, correct? So these are implicit functions. Now, not every xy or x into y is going to be an implicit function. Keep this in mind. Like I'll show you one more example. Suppose if you have xy is equal to x plus y. This need not be, because see, I can write this as xy minus y is equal to x. So y into x minus 1 is equal to x. So y is equal to x divided by x minus 1. See, I can separate the x and y. I can make this as an explicit function. So how exactly do we define an implicit function now? Now coming to the mathematical point, now an explicit function will always be of the form f of x is equal to some function, whatever it is. That means you are going to have a particular variable. Now always what do we take? We take y is equal to f of x, isn't it? So we are going to have something like this. This is for an explicit, remember, this is for an explicit function. Now, when we talk about an implicit function, so what we write is f of x comma y. That means both the variables will be part of the same function. This is when we say that the function is an explicit function. Sorry, a function is an implicit function, not an explicit function. Understood? So this is an implicit function. Understood? Now, let me give you different examples, and the part of this particular, topic, whatever you're learning is, How do we differentiate an implicit function? Okay, so we are talking about derivative. Now, in this, I want you to learn the chain rule very well. Because if you don't know chain rule, doing this is going to be quite hard. Fine. Let me show you an example. Say you have a particular type of function, sine of xy is equal to y square. And I'll ask you find dy by dx, or what is dy by dx. Whatever, simple. So first, we always start with the chain rule. Okay. Now what we'll do, see sine of xy, isn't it? What if I take xy as some function u? Some function u. This is going to become sine u is equal to y square. Differentiate with respect to x. So you will get cos u into du by dx is equal to, what is derivative of y square first? Y square will be 2y into dy by dx. So what we are trying to do here, we are differentiating with respect to x, correct? When you differentiate y with respect to x, you will get dy by dx. If you differentiate u with respect to x, you will get du by dx, isn't it? Whatever the variable we have, you are trying to differentiate with respect to x. That's all. So now cos u into du by dx, right? Let's calculate du by dx. In the sense, we are going to take this, differentiate with respect to x. Alright? So what we have? We have u is equal to x into y, du by dx is equal to. Don't you think you have to use product rule here? So if you use product rule, the first, that is x value, will remain constant and you can differentiate y, or you can just differentiate x, keep y constant. I mean, it doesn't make much of a difference. Anyway, it's positive. I mean, and it's commutative. So x, I'll keep it constant. Then x into dy by dx plus y. Derivative of x is 1, so plus y. So we are going to substitute this du by dx here. Substitution part. See, if you are going to substitute, so you get cos u. What is your xy? Cos xy into x into dy by dx plus y, 2y into dy by dx. Correct? So this you can also write it as cos of xy into x into y dash. Y dash is dy by dx, right? Plus y into cos of xy is equal to 2y into y dash. So on the left hand side, what did we do? We did the multiplication. Alright, so this gets multiplied here, this gets multiplied here. That's how you are going to get this particular value. Alright, take all the y dash on one side. Take all the y dash on one side. Fine. So if you're taking all the y dash and the rest of it, push it to the other side. Alright. So what we can do now, keep the y cos of xy on the left hand side itself. So you get y cos of xy is equal to 2y y dash minus x cos xy into y dash. On the RHS, you can take y dash common. So you'll get y cos xy y dash into 2y minus x cos of xy. Now what we need is y dash, isn't it? So keeping y dash as the subject of formula, that means you're going to isolate y dash. So y dash is equal to y into cos of xy divided by 2y minus x cos of xy. So this is going to give me the answer for y dash. So in the next video, we'll do few examples of how to do implicit differentiation. This is one example. In the next video, I'll give you a few more examples. So get comfortable, then we'll start solving problems on implicit differentiation.